You know, I start the stream up and I go grab a couple of water bottles, and I never know what I'm coming into over here. All right, tomorrow's here. Good, good. Okay, the cyber guy's here. Good. We are, and Tomato's here. That's awesome. We are working through some stuff today. I'm just kind of, I don't know, seeing what's going on. Saturday afternoon, wife went to watch a movie at her sister's house, and then we're going to hang out later. Normally, I would be kind of doing our Linux group this time, but I didn't set it up, so nobody showed up. So now we're just doing this. So let me drop it over here. I'm going to fix these because you guys asked me to fix these yesterday. So I'm going to I'm just going to cut all this stuff out. A little bit of tedium, but I got to clean this stuff up. I got to clean the labs up too. So I've got a few things to do. And anybody that wants to hang out with me while I do it, I guess can do it. That's what we're going to do. Going to get everything fixed up here so that we've got this system a little more set up for people going forward. Probably for the next couple of... actually, tomorrow we'll be doing labs all day, so I'll probably have these going while we do labs. But I want to get some more labs built up if I can. So that's going to be kind of a thing that we work on. Because we got to get the labs going. And able to chat the stream live. Let me see. Hold on. Let me make sure you guys can hear me. Yeah, okay. You guys should be able to hear me. Good, good. And you guys also, we have a YouTube. And I guess people like YouTube because it's more persistent, right? Like you can go look at this stuff later. I don't know why anybody would want to watch any of this stuff later, but maybe if you missed it, I guess. But one of the reasons I stayed away from YouTube for so long was I don't need anything persistent, right? Like I wasn't doing anything that important in my mind. But the people have asked for it, so I'm doing it for them. You know, people in the professional Linux users group have asked for it. One thing you guys asked for yesterday was for me to clean this up. You didn't like these little dots, so I'm getting rid of them. And we are going to fix up this stuff so that we can go through the labs. While we're doing other things, we can talk about these things, so that'll be kind of there. Yeah, Tomato, I think it's pretty good. I think it's pretty good. It's shaping up pretty all right for everybody, I think. The goal is to make this useful for you guys, make it useful for anybody that's interested in doing this stuff, right? Like, it's, you know, I'm not just here to hear myself talk. I get to hear myself talk plenty. It's more to show you guys that you guys can do this stuff and to get into this space if you want to, you know. It is not unattainable to get into the Linux engineering space. It is definitely something people can do. And then you can use this to go anywhere, right? Like you could do anything from here. So, all right, let me clean it. I'm cleaning this talk up because I know some of the guys wanted this cleaned up a little bit. So I'm just trying to get it cleaned up the way you guys wanted. There's our Discord for anybody that wants to join that and hang out in there. If anybody's watching on YouTube, which I know they're not, our Discord is the Professional Linux Users Group. If you search on Discord, you can find it, and I'm pretty sure it's an open invite for anybody that wants to join there. I don't think I have it limited really in any way, and you have to do something pretty averse. We've never kicked anybody out of there for fun fact. We've had 2 people leave that I know of, you know, that in a huff because of something one of the mods told them, but it wasn't me. And I didn't, you know, nobody's been booted. We've banned, we haven't banned anybody either. We've had to time 2 people out before for, they got their accounts compromised, but that's not the same thing as getting a ban for, you know, like talking about, you know, something you're not supposed to or whatever. All right. Anyways, let's keep going. I'm just cleaning this up. This is the talk from the other day, and I think I got most of them. All right. And then the one other thing I need to do, whoops, I missed one. The one other thing I need to do was to kind of make everybody happy was to take all of this and make it a little bigger, I think. So let's just go to home and, oh, that might be too big. Learning Linux through the Socratic method. There we go, boom. And then there, that's big enough. This one, how can is there a control key for this? Control Shift greater than. Control Shift greater than. I might need to... That might take a little too long to do. Alright. Tomorrow, you said random question today. Have you ever been involved in the CI/CD process? Can you talk about? Yeah, tomorrow I've done a fair amount with the CI/CD process. Yeah, so um, it depends on what you're doing, right? Like, but CI/CD is continuous integration and continuous delivery, right? So it's a software development model typically where we trigger things. And the way that I've done it, or the way that I've been involved in it, tends to be with my Ansible playbooks. It tends to be, so I used to write Ansible playbooks that we would then push up to our Bitbucket. Once they got pushed up to our Bitbucket, we would automatically test them in a lower environment to make sure that they worked and that they and that wasn't always an automatic process. Sometimes we'd have to go manually run it. And then once we manually ran it or automatically ran it, however we did, we tested it, made sure it worked in the lower environment. Then it was ready to be like handed over to another team. So, oh, I can't show you guys because I'm not on that network. I was gonna pull up my AWX and show you that with Tower, once I build something and once I test it out, I can give it to other teams to run my Ansible playbook. So then my other team that maybe we had something that would like reset all the disk, would wipe all the file system space in temp or something. And once we did that and tested it, which is pretty simple little playbook, and you say, why is it a playbook? Well, because then we can just hand it over to our operations team, our network operations team, our NOC, right? And they can, when they get a call or they get a SolarWinds alert that says, hey, temp is approaching 79% on that box or whatever, they could push a button and they can wipe it because it's a procedure that we've given them to do. And they can run that as though they were root against a set of servers, but they only have that permission and only on those directories. So that's kind of where I've used CI/CD, and it's basically I can hand stuff off that doesn't drop into production until we're ready to call it good. The place that I've studied CI/CD the most, if we were going to talk about that, would be over here in AWS. Oops, we don't want AWS training. Yeah, this is serious. We can go to AWS over here, and give me a second to log in as not that one, but as me, and then I think it's this. Nope. Maybe it's that one. I think it's that one. Yeah. Okay. And then this is where like a lot of CI/CD gets done up in the cloud. Is we come over here to code pipeline. So you've got code commit. That's your, that's where you push stuff up. Traffic King. I am so surprised that the last, like, I've been at two major places recently that use SolarWinds. Yes, even after the big compromise of like, what was that? Early 2022. AWX comes with the default Ansible. No, tomorrow you should have to install it separate, AWX, and in my home lab it's kind of its own little old install. I gotta check. I'm checking some drama stuff. Okay. All right. So code commit is where, you push the code up and then now you've got different versions of it, and it can function with all like the hooks and everything. So when somebody pushes a new version of code to code commit, you can automatically go run over here in pipeline. You can go run regression tests, all type of tests can be run against things. So here's your source of code commit. Here's the artifacts. So once code build gets done building your code, it goes and puts it up in artifacts. And then deploy can push that to your different servers, right, in your different environments. And then the pipeline can kind of run everything, and it can do testing. It can even kick stuff off to Jenkins and all that kind of stuff. So this is where, like, so code pipeline really is like your thing that you can do. And I think they had one called CodeStar too, but I think CodeStar kind of got deprecated. I don't know if it's still kind of thought of as, but this is all CI/CD type stuff. That's the whole idea of CI/CD still. And they talk a little bit about no additional charge for using it. You only pay if you do resources with it. And that's how every one of these things are. Like code commits the same way. You don't pay anything to use code commit or code pipeline. You pay to the traffic that you generate and the files that you do. Look, I had a little ProLUG test one up here for when I was doing my Lambda code. And I ended up writing all my Lambda code directly, but this code commit test is tied back into my AWS stuff over here in, I think I have it over here in AWS work over here, right? And then the stream test Lambda function, I believe, actually writes up into here as test or something like that, right? So anyway, so that's something that you could do. Let me see if I can't. Hold on, real quick. I'm gonna try to keep finishing this real quick. I just have a few things to do here. Can I just do Control Y? Nope. Control Shift greater than. Oh, damn it. How's that? There we go. Okay, what is that size? That's 96? We'll just go down and do that on all of them and see how that looks. 96. And I think after we do that on each one, I can, hold on. I think after I do that, I can just do Control Y now. Hold on, so let's see. Should be able to do Control, nope, well, let me do it. Control Shift. Ah, well, we'll do it this way. Some of these can't go that big or they're going to mess it all up. Tell me the architecture of this ship. I know, guys, this isn't the glamorous part of it, but it's we got to get it done, right? Gotta do it all. Gotta get it all looking good for the stream, right? And I'm just working on this stuff. The other stuff I have to work on has to do with my my doctorate. Although I got most all the stuff I need to so far done. But if you guys have any questions about any of this other stuff, let me know. You guys didn't like the blue dots, so I'm getting rid of them. And going to 96. Boom. And then something like that. 96. There's no shortcut that I know of to do this, so I normally know plenty of shortcuts, but I don't have a shortcut for this one. So just got to do it by hand. If any of you want to answer any of these, you can. We were doing them the other day. So can you tell me how much of your cache memory you're using? Typically we have a lab that you could do it in, so if you guys want to do it in any of our labs are here. And you can feel free to mess around in there if you want to do that. All right, I'm just putting these together. So there's our file system topics next, and then can show how much is in the root partition. And again, this was just a recommendation from you guys yesterday because it didn't look as good as you guys wanted, or well, so for some of you. We did a vote on it yesterday, how it was going to look. Some of these aren't going to fit like that, but we're going to try to get them all to fit if we can. 96. Boom. All right, so if we can't do that, we're going to do a Control A. Whoops. Do Control A, and we're going to make it just smaller, so like 88. 80. There we go. 80 is fine for some of these. That one's almost as big as it's probably going to be able to go. We'll see. There we go. All right, networking. Can we keep going? All right. Again, I don't normally like doing this stuff on stream, but I'm just hanging out today. It's not a normal day for me to stream anyways, so, let me know if you guys have any questions or anything. And we will keep working on stuff. I've got a presentation to start putting together too, which I'm going to start doing. And that will be around our going to be around moving to the cloud. I got to start working on that. That's for a thing at work that I'm doing, like a talk on that. So if you guys want to, damn it. Super annoying. All right. You determine your default route. Do you guys know how to do all these things? Kind of important things to be able to do as a systems admin, systems engineer. Knowing how to kind of work around in the system is a important set of tasks. Can you determine the maximum transmission unit of the network with ping? Talked about that one a little bit. 96. Can you list all your ports? Important. Can prove that DNS is working. That's also very important. What file do we edit to change the service number? That's Etsy service, right? Etsy services. Been in there and messed with that. Very important. Can we connect to another server and test? I'm gonna make this 88. That might be just a little too big. This one's probably gonna need to be 88 as well, if I had to guess. This one might need to be even a little smaller, like 80. Yep. This one might be the right size. There you go. This one might be pretty close to the right size too. Okay. Disk topics. Oops. How big are all these ones? 96. Okay. Not too bad. All right, we're almost done, guys. We're almost done. We're nearly done, I guess. See if we can get all the fit. Check the disk I/O over time. Can read and write and verify the disk speed. Okay. Do we know who's logged into our system? Do we know what port and process is listening to what on our system? It's very important. Can you tell me how SSH daemon was started? Should know how to do that as a systems admin and engineer. Very important. Can you make sure that it looks like your other nodes? That's important. Move that down. Listing all the kernel modules. Can we tell what's going on in there? And then can you verify that a file hasn't changed in the last few days? How do we do that? There's tools that do that, but can we use the system tools to do that? That's important. Let's make that one bigger. There we go. Boom. That's big enough right there. Alright, can you encrypt a file, text file with VI? We did that one on stream. It's just VI dash capital X, right? and then your system will use Blowfish 2 encryption. That's a fun one if you never played with that. And I told you guys to go look that up if you're interested in kind of seeing how the Blowfish algorithm came about. It's a fun story. For any user, can you determine their sudo permissions? That's sudo-l-U, right? If you don't remember that one, that's very important from a system standpoint because you need to know what your users are capable of doing. That's a good one. It's really important. General systems. Okay, we're almost done. Don't have too many left. 88. All this down. Can you tell me how the system was booted? It's important. Can you tell me what the running version of the kernel is? I think most people know that one. It's uname-r or uname-a if you just want all the info. Okay. Make that one smaller. And then this one 90. Yeah, this is the mind-numbing part of it, guys. This stuff doesn't really do anything. Can you tell me the Linux version you're using? That's cat etsy splat release typically. Or DMID code and look at the top. Might help you out with that. Oxidant Prone, hey, thanks for showing up. We are just going through and making this a little more of what you guys asked for. Everybody said, hey, can you do this a certain way? And I said, I'd give it a college try. Which any of you that know college students know that that's not a very hard try. Alright. Alright, I'll stop joking around about college students. I'm only mostly kidding. User environment. Wish there was a way to just make this expand to the whole screen, but I don't know of a way to do that. All my little tricks for productivity, nothing do I know that will make PowerPoint just do things for you faster like that. Typically you gotta do this stuff by hand. PowerPoint's one of the more useful tools that they've got over here. On the Microsoft side. I don't normally go in for Microsoft, but this is one that's okay. Might not be able to go any bigger on that one. Bash scripting? Don't worry guys, we're getting there. Just we're taking our time to get there. Okay. Yep, and we're just working through stuff slow, guys. I apologize. Normally I have a little more of a plan for what I'm doing, but right now we're just kind of winging it. And I got to work on some stuff. We didn't finish the lab yesterday, so I need to finish up the lab a little bit and get that one published, and then we can test that one out a little bit for anybody that wants to do some Linux with me. And that one's a little bigger than we need. Okay. These are all of our bash questions. Can you make your system count to 100? Kind of important. Shows you can list a bunch of files out and all that good stuff. Oh, there we go. Can we do this? All right. Painful, but we're pretty much done with it. Can you test against the known variable? Yeah, that's all good. All right, get that stuff out of the way. Home lab. We have to finish this up real quick so I can get this going, and then we can test the lab out. All of our labs are here. I will link the one as soon as we get it done, and then we can mess with it a little bit. Mostly kidding. Okay. Let's come over here to Linux Labs. We got to finish this variable one, so we'll pull this stuff up. And yeah, we were down here. I think at the end we were just going to add the exclusive and and or logic at the end here. So let's pull this up and we'll get that going, and then we'll kind of get over to some of the other stuff. So for our labs, by the way, anybody that needs our labs for any reason, there's a GitHub. On the GitHub, you can find them under ProLUG Labs. They also link over to the lab stuff that I just showed around Killer Coda. So, right, so you can go to Killer Coda, find the Heptanus Labs, which is the ProLUG Labs, and then you can go find kind of everything in there and mess with them. All right, but over here we're doing this part, and we're going to say, now that you've done some basic decision logic, let's add in inclusive or and exclusive and to the equation, right? So we're going to add some things, we're going to remove some things. Hey, there's Robodom. Hey, Robodom, we didn't do the Linux group today. I forgot to make a thing for it, and then I was just down there hanging out in one of the study group channels, kind of working on my college stuff, and I didn't see anybody pop in until like 3:15. So I was like, I guess we're just skipping it for the day. Yeah, I wasn't too worried about it. It's one of these things that's kind of like we're chilling into the holidays, and I think this happens every time like Christmas and Thanksgiving come around. You know, like people are getting ready. It's not quite travel time, but it's like getting here soon. In fact, my son and my wife have all of next week off. I was thinking of a fun fact. Here's a little fun fact that I was actually I was thinking about this yesterday in the shower. I was like, because it was, I mean, I take showers later in the day, right? Because I work from home. I don't have to shower before my first meeting or anything. And I was taking a shower like in the middle of the day, and I remember thinking, my wife's gonna be off, and she's off all next week, so she gets the whole week off, and then her birthday's the 26th, so my wife's birthday's coming up, right? But this is the funny thing, Robodom. This was my exact thought. I was like, I make almost, if you take into account my college teaching, I make 4 times as much as my wife does. I only know that because I'm the guy who keeps all the books, right? But I make 4 times what my wife does, but she gets next week off. So I was jealous of her for sure. Also, it doesn't matter because, you know, we've been married for a long time, so it doesn't really matter who makes more. But I'm just saying, like, it was just kind of a funny thing that I thought that I'm like, yeah, the side note on my shower routine. Yeah, Robodom, I don't tell you guys that for any reason other than, you know, you don't have to get up. When you work from home, you don't have to get up and do that right away, right? Like, you can roll into your first meeting. Nobody's going to notice, you know, if your hair looks like you combed it with your pillow or whatever. All right, so now we've done some basic logic. Let's add some stuff in. So we're going to add in a check that checks for both SSHD to be on and HTTPD to be off. And that's going to do this. It's going to say if HTTPD check is on and SSH is off, then the system is good, right? And that's an AND equation right there. See if that comes out with your expected output, then break it and see if both of them have to be true. They do. Right? Because with an and, both of them have to be true or it's not going to be true. Right? So then we're going to say down here, we're going to come down here. Hey, thanks for the follow. Bathhoven TWJ. Hopefully this stuff's useful to you. That proves the non-existent pay gap. You work more, you get paid more. Yeah, well, I also, it's funny, my wife has not changed her job role in the entire time I've known her. I met her 20 years ago when I got out of the Army. In fact, no, this would have been around the time I was interviewing 20 years ago. So yeah, somewhere around now was the first time her and I ever met. Because she was working help desk when I went in for my interview at the school district that she works at. She hasn't changed her job or her title once. I have changed my job and my title at least 20 times in the last 20 years. Like being promoted to a new role or moving to a new role even within a team or something. I change that all the time, right? That kind of happens a lot in engineering. Let's change this to an or. And the or is going to be, now let's try it with or logic. Let's try it with or logic and see that behavior. Okay, this should be here. If HTTP check equals 1 and that, or that equals it, then this system is good. Oh, no, we don't need that. And then we say, can you break this one? Does it matter if one or the other is true, or one has to for this to evaluate? And only one is needed in the inclusive or. All right, that's all that's needed in a system like that. And then let's go to verify here, and the verify for this will just be been true. We'll just allow that to be like the easiest verification ever. All right, so if that's done, and that's our variable logic, and let's make sure that the finish says, look at you learning Linux. You captured variables, did decision-based output, and then looked at and or logic. Right, you did all those things. That's what we did in this lab. Let's make sure that the index says variables and conditional logic. Good. The intro says welcome to ProLUG Linux. That's all the things we needed. Here's our structure.json. It's got that down here. All right, we're good. We're ready to push it. Pushing new lab, right? So we'll push a new lab up. And for any of you that haven't seen how that works around here before, it's going to look like this. We're going to get a new, oops, not Kaggle. Kaggle's good, but Kaggle's not what we're doing right now. Also, by the way, you guys might see me doing Kaggle more in the future here, just because I'm going to be working on some of my data analytics and data science stuff more. So I'll probably be doing that more on the stream and stuff, messing around. Where do we go? We're not on popular. Oh, we're up here. I thought we were on popular, and I'm like, where'd we go? No, we're down here on this. So I'm going to give you guys a link to this. Cypher Enigma, thanks for coming by. Our new lab should be coming up here in a second. We should see, if we go to creator, we'll see it actually pulling the webhook here as soon as that pushes. See the webhook's running? And it'll say last updated, and that's right now. Yeah, that's today, even though it's UTC time, so it's a little more advanced, more ahead. Hey, I think that's Andre21 US. Thanks for the follow. All you guys following, I always appreciate that stuff. You know, you guys, follows are free, and I appreciate when you guys do them here. Let's go look at our new Linux lab. So we've got a new Linux lab. It should be right here, and it should be called Variables and Conditional Logic. So I'm going to link this to you guys. And there's Robodom with our Discord, so you guys are welcome to hang out down there. And let's pin this lab. Look, guys, I expect this lab to be kind of busted. It'll be coming up here in a second. See, it's not created yet, so it'll take a few seconds. So give it a few seconds. For you guys that have been around and gotten into Killer Coda before, you know it's free. I don't charge you anything. Yeah, Salty, this is, and if you weren't around, Salty, this one will be this. You'll like this one because it's logic in Bash. It's variables and then decisions and then logic in Bash. So we'll do this one real quick and we'll see how it turns out. We're testing it for the first time, Salty, so I fully expect it to break all over the place, but that's half of the fun of this stuff, right? Also, by the way, you guys know we've got YouTube over here. And yeah, and if you guys don't follow Salty, Salty's where I go when I need help with stuff, right? Like, especially in the programming space. So let's see what some of the basic things, and I don't think you need that much to be good at procedural top-down. Now, guys, for scripting, we do procedural top-down scripts. That's how we write scripts. That we don't do. You can do functional stuff, and you can get a little bit over. I wouldn't say you can do anything object-oriented, but with scripting, you have these very simple tools, but they're exceedingly powerful for what we want them to be kicked off for, right? Like from cron jobs and from triggers in an environment. So let's test this and let's run through this. I'm going to read it. We're going to do the whole thing like it's an actual Linux lab. You are a new system administrator at a company. You've decided you need to start gathering system information so that you can use it in scripts, right? Like maybe you've read about that, or you've been to this site I always tell you guys about, tldp.org, which is like the reference guide for the internet for doing Bash type things, right? That's the best place I can show you to go learn how to do Bash. Like when I need to look up how to do a while loop or something, that's where I go. Hey, Colkiss, thanks for the student. I always appreciate you guys letting me know when you're here, and I do always appreciate you guys like wanting to be here to learn some stuff, right? So you're new systems admin. You want to use scripts. You know that this will give you more capabilities for automation and collection of the system state. Like you're in a system, but it's just a black background with white or green letters. That's all you have. So how can we start to get information out? So the questions here, yeah, and there's RoboDom. Do all the Linux. That's like, it's probably my favorite little thing. And I don't know if I've told you guys, there's only one thing I know how to do in a GIMP, and that's to build those little burn-ins. So when you guys see me do like all those burn-ins like that, that's the only thing I know how to do in GIMP. All right, check your Bash environmental variables, create some variables with system data, and we'll put system data in there, and then we'll output the variables to the screen, right? Can we do all these things? So here's some environmental ways, like, and actually this declare-p was one of my favorite ones. Somebody came up with this the other day for us. But what can we do? We can do print environment, and that'll tell us a lot about the environment we're in, the Bash shell that we're running. By the way, how do I know it's a Bash shell? It actually says it right there. That's my shell. How do I know my working directory? Right there. How do I know my home directory? How do I know my log? All these things are in my shell environment. By the way, everything here can be tested and used as we get into these other parts here shortly. Everything is a test, right? A conditional test. I can do environment. Environment gives me a very similar type of thing. Environment will show me a lot of stuff. I can do a declare-p, and this one was fun. This one gives us a lot of stuff in the environment and shows us a lot of the things that maybe the other ones don't even show us. There's a lot of information coming out with declare-p, and you can use any of this inside the system for information, right? And a lot of the stuff is kind of like a key value pair, right? Different stuff that's going on. I can also use set. Set is one that Sending Ground uses, and set gives you a whole bunch of other information, and all of these are variables that then you could use to pull information out of your system, right? These are all variables that exist inside of your shell, and you should be able to echo them out. Now, I've never tried to do some of these, but let's do this one. Let's see if I echo this, if this will come out. Yeah, there's a shout out to Sending Grounds. Yep. And you've got like a $, whoops, $, and then just Control-Shift-V for the HIS file, and there. So these variables are all callable from the command line. And I've showed you guys this before. You can change your PS1 variable if you want. That's your default shell, your default command operator there, right? Like, that's the PS1 variable, and you can edit that if you want. And we do that in other labs. But I say, is there any difference between all of them? Well, we can just run this and see real quick that print env and env are probably pretty similar, as are declare and set. but they're not exactly similar. So there's a little bit of differences. So you might have to go play with them. But if you said, hey, does print env and env give me the same things? I'd say, yeah, they're probably pretty close. Might not be exactly the same, but they're pretty close. And then I said, let's go ahead and test out the output of a variable named name. And we do that, and it gives us no output. And the reason is because we called a variable by name. We went and looked in a box, as it were, that had nothing in the box. It's like the end of what is it? 7 Deadly. What is it? 7. Yeah, it's called 7. It's like, what's in the box? There's nothing in the box. We didn't put anything in the box. So we can put something in the box. We can do a uname, and uname will tell us Linux. Uh-oh, what happened here? I broke something here. Probably. Oh, I have an error in my markdown code. My markdown code. Oh, you know what? My markdown code can't use that. This is something. By the way, guys, this is something we found in the labs before. This is why we use the other value. So I made a mistake here, guys. I apologize. Right here, these backticks. I can't use backticks. They're a special character. I have to use $sign and like that. So I broke it. That's my own fault, and I'm gonna do it. I'm gonna fix it here. $sign open paren and close parens, right? And then also, well, I don't know how this uname worked. that shouldn't have worked earlier. Oh, that was probably the one that failed right there, huh? Yeah, okay. And then, do I have any other ones like that? Nope. I'm gonna hit Control S and save it. I'm gonna go check the other ones before I commit this though, because I'm pretty sure I did that in other ones as well. So let's see. Nope, I didn't do any of the other ones. These ones are all fine. These ones are all fine. I'm looking for backticks because backticks are special reserved character in Markdown, and you can't use them. I don't see any there, so that's fine. And let's go here. Let's make sure I didn't use any backticks anywhere. I did not. I did not. Okay, good. So I'm going to push this code up. Fixed backtick error in Markdown. Right? You got to know what when you write anything that looks like code, you got to make sure. I'm watching a file is watch-n5 ls-lh. Nice. Salty, there's many good ones. There's many good ones. In fact, Salty, I have like a little call for, questions for you guys down in there. And I want any questions that you guys have around system stuff. Things that you like, things that you want me to ask. Because these are all the questions that we were asking. And Robodom, if you got here late, I was fixing them earlier, so that was kind of a little tedium when the stream started. But these are all the things that are going to pop up in the top right of the screen as we go for people to think about, right? So if you have any questions, they're down in the Discord. If we pop in Discord here real quick. It's called like call for questions under resources. And you can just let me know. So these are like some examples. Can you tell me how the system was booted? Can you verify a file hasn't changed in the last day? If you had some that were like, can you, I don't know, tell me all the system users from Etsy Pass WD, right? So some people know how to do that stuff, right? Like these are just examples. Can you tell me all the system users from Pass WD is all the accounts that are between 0 and 199 are system accounts, right? And then 200, so number 200 through 999 are software packages that were installed later that put users onto the system. And then user 1000 is the first user created, and user 1000 is the one that starts. Yeah, Robodom, this just was just started. I started as like as a thread yesterday, I think. Also, guys, for people that are newer or interested in doing stuff, we have Ben is coming to talk data analytics with us in a couple of weekends, and then we've got our inaugural Christmas party, our holiday Christmas party coming up on December 16th. And you got to look at it in Discord on your own time to see when it's coming. But you guys are welcome to come to any of those, and we're going to hang out and talk shop and, you know, play around and do whatever we do, messing around in there, right? All right, so I fixed this lab. The lab, by the way, you need to refresh it if you're in there, and it may take a little while to take. So I think I've given it enough time. What's the dress attire for that, Robodom? You can wear a dress if you want, Robodom. You can wear whatever you want to the Christmas party. I'm okay with it. You can wear whatever you want. The dress is whatever. If I have some of the guys local that want to show up, so like if Paul Hartle and Michael Pessa and Faint Calf I only use their full names because that's their names online. But Faint Calf doesn't give his name out online. If those guys want to come over and do it like downstairs, and then we could just hang out with like a camera on so you guys can all see us, we could do that too, and just kind of hang out and talk shop. Probably play some of the games down in Discord, that kind of stuff. Like it'll be a good time, I think. It's our first one too. It's our first one where we're trying to work on getting more organized around kind of hanging out and stuff. Because like engineering is hard work, right? Engineering, teaching, learning this stuff. Like you Robodom, he really is. Like he has been doing cybersecurity as long as I've known him, and then some. And even before he was out in the civilian world doing it, that's what he did in the military. Oh, Robodom, you should see this stuff I've seen. Like, we would go to lunch. Let me tell you guys a Faint Calf story. If you guys want to know about what you should or shouldn't tell him online. Did you guys ever see the one time Chicken posted a picture and he told him exactly where it was in New York? Did you guys see that? It was a year ago, maybe a year and a half ago. Like, Chicken showed a picture of like a little lake in New York, and it was just like as he was driving to work, and he told him exactly where it was. And then he did it on another picture for somebody's house. He didn't dox the actual person, but somebody posted a picture of somebody's house, and Faint Calf went and found exactly where it was. Now, there's a lot of like little things that you can use, like if there's numbers on it, and there's only so many numbers. Like even if you go to Zillow, there's only so many numbers. Like if I told you the major numbers of my house, there's only like 8 houses it can be, and when you narrow it down to Phoenix, you'd immediately find it. Well, Glendale, but you know what I'm saying? Like Arizona, anyways, you'd immediately find my house. But my point is, I used to go out with him to lunch, and he would sit there, and he would see everybody walk in. We would sit typically where we could watch everybody walk in, and he would get people's names off of their badges. He would get like their name, and they work at like Cyberdyne or something, and then he would look them up on LinkedIn, find all of their people that were like connected with them and stuff, and then he would go and run into them when they would get a drink. He would like go up and talk to them and be like, "Oh, hey, you're whoever from there. I know whoever over there from the HR department." And he would like strike up a conversation with this person on something that had never happened, and he would like just get information about the company from people. You guys think I'm kidding about that? That's seriously what Faint Calf used to do. We would sit there and watch him and be like, "This guy again." He used to do all this stuff, man. Yeah, he's an Ozone guy. He's also a cryptographer, and he was one of the leads. I gotta find the name of that site. He always posts it, and I always forget. But it's like a global map of all Wi-Fi. I forget what it's called. Oh, it's Wiggle. Yeah, it's Wiggle. He was like top 5 in the world on Wiggle for a long time, because we would drive around and he would have he's got his little Wiggle thing set up. You can go look at it on the Discord if you want. I think it's under projects. He might have it under projects. But when we would be driving back and he'd be like, "Oh, I got to turn into this office." We'd be like, "Why?" We're like going back to the office to like go back to work, and he would drive by and just map all their Wi-Fi with his little Raspberry Pis, and then he'd get home and he'd upload it with all the the geo data and that, and he would add to these maps everywhere he went. This is what he did. So like that's why I like when he comes and talks to you guys, because that's the stuff he does all the time. This is like what he like. That's a cool little site. But yeah, it's all the found networks and all the unexposed the exposed networks that are out there. All right, let's do our lab, guys. You got the lab. It's pinned. Anybody that wants to do it can do it with us, and hopefully it doesn't break right away this time. You're a new sysadmin. You've decided to start gathering information. Let's go look at our info. We can do our print env. We can do our environment. We can do our declare-p. We can do our set. Boom, all those commands work. We did our everything to get the values. Good. Now we see that we can echo name, and there's nothing in it, because again, it's a box with a label on it, but there's nothing in the box. So it doesn't matter that the label on the side says name, because there is nothing in the box, right? So then we're going to put something in there, and let's see if when we re-echo name, now what would have been in uname has been put in there. You got to remember this one equal sign like this. It's a tricky thing. When you see one equal sign, yeah, what's in the box? The one equal sign is actually, it's much better. I learned this, I think I told you guys, I had a Java programmer in college who had written the book on Java. And when I say the book on Java, his book was in like 900 colleges. It was huge. And he was teaching at DeVry. And I always liked his explanation of, this is like a little dump truck. This is not an equality operator. This is to set a value. right? So this is whatever's on the right gets dumped like this over to the left. Equals equals sign in most languages is a test for equality, right? But not in Bash. In Bash it is actually, but in this case we're testing that. We're not testing anything. We're setting the value to the left, the label as it were on that box to be whatever the value is on the right. If you want to think of it as like one of those little things like sliding something into a box, whatever. If you want to think of it as a dump truck, whatever it is, that's what it is. Okay. All right. So now we're going to set some values. We're going to do a ps-ef, and we're going to grep for HTTPD, and then we're going to set the check to be the return code that came out. Now we can test that real quick if we're curious. Is it the same? Yeah, it's the same in Python Occident. You're right. Yeah, when you set something, it's absolutely right. Let's test this real quick. Let's echo $? Like that, and I see that it's 1. And the reason it's 1, x equals y, x are all different. Salty, I have no doubt that that's true. Oh, by the way, Salty, I needed to talk to you. If you are interested in doing any more streaming, than you have been doing, specifically around like your scraping stuff, I love that. Beautiful soup, all of that stuff. If you're interested in doing that, I'm going to be doing more of that myself, because I'm always keen on pulling stuff. Like you guys have seen, I can pull stuff and hit stuff out of APIs, but I need to start turning my stuff into like in my DBA. Like, man, I've spent the last week just reading about like the rigor of like academic gathering of data and stuff, and like I can do all of this stuff from all the government sites that are out there. So now I just need to start building my methods, working on that stuff, and making that stuff working better. Yeah, Colchis, that's something I've seen Salty do. And if you guys want to hear, this is probably, I was talking to my buddy Ben that's going to come, and I told him when this happened, I'm like, this is one of the, if this isn't the most, I don't know how to say this. I wouldn't say, this is definitely out there. But when Salty did his talk a while back, he talked about scraping APIs, and when he did, a couple months earlier, Chicken had told us he had moved jobs. He had moved over, and he was in charge of API. He was the API architect for some new company. But, on Discord, we don't always tell each other what we're doing exactly, but we knew that he was doing API stuff. So then we're sitting in there. There's about like 10, 12 of us. I forget exactly how many. But Salty's like, okay, I'm going to show you guys the vulnerabilities on this website called Pluto.tv, I think it was. Yeah, Pluto TV or something, right? This was great. And he's like, okay, so now once I get access, I get this key, and I don't think they mean for me to be able to do this, but even though I just had guest access, I can use this key for 24 hours to check anything in the API. And Chicken pipes up and goes, I'm the new data architect for that company. There's like 10, I mean, what's the chances that with like maybe 15 of us, it was a bigger group that day, that one of them was going to be attacking a website without knowing that the other guy was the new architect of security for APIs on that same website. It was insane. I mean, it was like, I remember telling one of my buddies, the guy who's going to come, Ben, and talk about data analytics to our group. He's got a PhD in, or he's working on his PhD in economics, and he's got a master's in, I think it's economics and mathematics are his master's degrees, and he teaches over at a UC Irvine, and I told him, I was like, we could try to calculate that, but I'm sure that's some infinitesimally small number of chance that those two people would be in there. Of all the engineers and all the bars and all the whatever of the world, you walked into this one, right? What's that from? Who knows what that's from? All right, so we set that check. Now we're going to check SSH, and we see that it is there. But now if we check those variables for the output, can I see if I just echo $SSHD check? It's 0. So that was good. That something did come out from that check or whatever. Tomorrow, were you there? Yeah. I forget who all was there, but it was a really small group of us to just be like, hey, I'm attacking an API that you're now responsible for. He wasn't attacking. He was just showing that, like, I don't think this is a behavior they expected. I shouldn't just be able to check in as like a guest and then have full access to pull channel. It was like their channel stuff, which is normally sitting behind, because you can't get directly to that stuff without logging in. But if you just go in as like a guest to view the stuff for even a minute, then you can use that key for 24 hours. And I'm 100% sure they fixed that since then. But Salty can show us if they haven't, right? Okay, so we checked all that. Validation successful. Now I say test the decision structures of Bash. There are 3 types of decision structures: single alternatives, dual alternatives, and multiple alternatives. APIs can be obfuscated, which just makes some work to get into. Of course, yeah. Test each of these structures with variables that you have from the previous step. Okay, that looks like that's right. I might want to write a little more on this, but that's fine for now. So what we're doing is use a single alternative structure. So the way the 3 structures work, and I know I'm not telling Salty anything he doesn't know, but for other people, the single alternative structure is my code is walking procedurally from top to bottom. When it gets to the bottom, it's done executing whatever it's going to do. But what happens with a single alternative is as it's walking along, I have a little check that says, if you see a stick, do this thing. But if it doesn't see a stick, it just walks on by it. That's totally different than a dual. So nothing has to happen in a single alternative. If you come down and there's nothing there, it just goes on. But a dual alternative, which we're going to talk about after it, is forcing a decision. You must go left or you must go right. It sends the program to a fork in the road. And then there's multiple alternative, which is also sending the program to a fork, but there's multiple tongs or tines on the fork, right? Tines are the technical term for each of the things on a fork, right? Hey, Hans, so hi. Hopefully this stuff's useful to you. Let's go through our logic here. So this first one says, if it's 1, check and then echo out that HTTPD is not running, which we know is true. And then can we check to see that SSH is running? And yes, it is. And then I said, are these outputs that you expect, can you make them logically incorrect, but still working according to their syntax? Now, I don't talk about this here, but from a computer science standpoint, there's 3 types of errors. Does everybody here know that? Does anybody? I mean, look, I'm a computer scientist, but I'm not a programmer. I don't go and like dig in to be the most efficient I can. But I know the 3 types of errors. There's 3 primary types of errors you're going to run into, and they're more insidious the further you go down. But the first one here, let's fix this one. It says fix it according to its syntax. I'm going to break this, but make it still work. It's just not going to work logically. All right, so here's the types of errors that you get. The first one is the syntax error. Syntax errors are easy. Watch this. That didn't work. The syntax was busted, right? Now, if we go back here and we run this, this is going to work in the syntax. This is going to have functioning, effective syntax, right? But what's going to happen, let's go here. This is the syntax of this is going to be fine. But when it runs, it doesn't have the variable that it needs. So this is a runtime error. Everything checked out fine here. But then when it went to run, it broke. There's an expert in syntax errors. Yeah. Yep. And then the only error is user error. Yeah, and we went through all the user errors yesterday, right? Pebcac, Picnic, and ID10T. And what was the other one? Somebody had a really good one. Oh, layer 8. I thought layer 8 of the OSI model was pretty good. The most insidious type of one ever is this. It's set right, so it passes syntax. It's set right so it passes runtime, but it fails right here. It fails on the logic. Logic is the most insidious type of error because syntax errors show up right away. Syntax errors are real easy to see. It's busted. It doesn't work. Runtime errors are a little easier because at least you run into them eventually, right? Typically pretty quick in the scripting world, right? But a runtime error is just something's not there when it's needed. Runtime errors can be race conditions, like you're setting a variable over here, but you checked for the variable before you set it. Bad. Don't do that, right? But then the worst type of error on all of planet Earth is not going to be syntactical, and it's not going to be runtime. Your shit runs fine. It just produces the wrong output. That's a logic error. That's on you, right? Thanks for the follow, Ginger Soul. Hopefully this stuff's useful to you. I do appreciate follows. They're like, following and lurking is the backbone of Twitch, so I definitely appreciate any time somebody follows. By the way, we're at 2,928 followers. I'm not really like super concerned with that. Like I'm not gonna like put up one of those little banners that say, "Hey, we're almost at 3,000," but hey, we are almost at 3,000. Also, we just broke 900 on Discord, which, again, Discord's always going to be free, so it's not like I'm charging anything over there. But yeah, we're trying to get like a big like community of people interested in doing this stuff. And by the way, guys, we also have all these people We got Sending Grounds has his own Discord. You guys should hang out in there. The Salty Catfish has one. He does a lot of movie stuff down there, but he talks programming down there. You guys are welcome to follow all of these, right? And I would follow them on Twitch and then go watch what they do and see that you like their stuff. But like these are the guys that I go to because they're senior in their space and I need to ask them questions, right? Just like, and this happens, people come to me and ask me Linux stuff and then I go, I don't know, because I never know. But the point is, people come to me because I'm good in my space, supposedly, right? All right, anyway, so we come down here. So again, important thing to look at with this as a logic, as a single alternative, nothing had to happen. If this logically didn't find a test for true, the program just kept executing procedurally. It didn't care. This next one we're going to do, and again, I apologize, you got to move these over to see what's going. Instead of just being if-then with an end-if, which is a phi, now we're going to do an if-then-else. We're going to force, when the program falls into this part right here, it is going to force it to go one way or the other. The same thing here. Now you might say, Scott, hold on a second. The output's the same. You're right, the output is the same as this. But the difference is, up here, nothing had to come out. Here, one of the two things, either this, that if this tests true, then this, else that. Something had to happen. This program executing had to do one of two things. That's how a dual alternative structure works, right? Like it forces something to happen. And I know that I'm like, sound like I'm beating that up, but I know not everybody here has ever done computer science. So this is the way that we do the logic, right? This is how it goes. Then the next one is multiple alternative, which can also be called a case. So now I say use a multiple alternative to output to multiple possibilities greater than 2, anything greater than 2. So I'm going to hit this, and it says that SSH is running. But now I'm going to set SSHD, whoops, over here, SSHD check is equal to, I'm going to just set it to 5, right? And now I'm going to run that. And it says something is really wrong, because now we have to say, hey, Last Chain, how's it going? You're over here from Rob's. I haven't seen Rob on but one time this month. Is he like traveling, or what's going on with him, Last Chain? But you're always welcome here, and I tell you guys all the time, I don't want to take anybody from their favorite streamer, but you're welcome to follow me. You're welcome to hang out here whenever you guys want. In fact, you're welcome to lurk even if you guys don't want to talk. You guys literally, I don't even think I could stop you from lurking even if I wanted to. Like if I was like, Last Chain, that's it, I've had enough of you. I don't think I could do that even if I wanted to. But I would never do that. I would always get rid of Robodom. I'm just kidding. Robodom's great. But yeah, if you guys don't follow RWX Rob, you definitely should. He's the reason I stream. Not because I saw him streaming, but because I was doing this stuff, and I was just like, I wasn't getting any traction. I'm like, why the F am I doing this? I'm a senior engineer, like principal, really. I train people all the time that want to listen to me, and I have my college students, and they have to listen to me whether they want to or not. I was like, why am I doing this? Like, this is just... And I was hanging out in one of his streams one time, and I said something, we were talking, and he and I kind of knew who each other were, because he'd raid me with a bunch of people, and I'd raid him with like 3 people. And he told me one time, he's like, don't you quit. He's like, don't you dare quit. And I was like, all right, Rob told me not to quit, I'm not going. And I was going to. I had been doing it for a few months, and I was like, this is stupid. Why am I doing this to myself? Now I've been on here for a while, and it's like, I have fun with it. I have fun with it, and the goal is to make this stuff like accessible for any of you, because again, I tell you guys all the time, you don't have to be that smart to do this stuff. You have to be smart to be some of these guys. Like, you go watch, I was watching, and I don't even like the guy, but I gotta give him respect where it's due. I was watching Primagean do some of his structures and node endpoint stuff, and I was like, you gotta be pretty smart to do that stuff. I'll give him that. But for a lot of this stuff, I don't think you need to be that smart. Like, basic engineering is just following a set of processes. Even most mathematics, you don't have to be that smart. You just have to be able to churn through a bunch of processes to get there. So, all right. Yeah, Cold Kiss, I always appreciate you guys being around. All right, so we did all this. We tested this. We got different outputs than what we wanted, and we saw these things happen. So that was this whole thing. Now we're going to do some conditional logic. Validation was successful because I just test for truth. By the way, guys, this lab is pinned, so if anybody wants to do it with me, you can. And I said, now that you've done some basic decision logic, single, dual, and multiple alternatives, let's add in an inclusive OR and an exclusive AND to the equation. And we talked about this the other day, but let's talk about why OR is inclusive and why AND is exclusive. Think about this real quick. If I tell you I went to the store and I went to the movies, I tell you I went to both of those places, and then you find out later I only went to the store. Did I lie to you? I went to the store and I went to the movies. That's why I was gone for 3 hours. And you go, I found out you only went to the store. Well, that's a lie, right? And look, guys, there's a million of these out there. You can look up your truth tables for testing logic. I'm not going to go through all of them for you, but there are like truth tables all over the internet that can show you if it's this or this, it's a truth or a false. There's guys, look, these people can all do this better than me. But I can explain it to you and then tell you, go look at this, right? And this is anding logic right here. 0, 0, both of them are false, false. 0, 1, false. That's an anding logic. Only when both of them are true is an and true. So we can say that an and is an exclusive because you need more things true for ands to evaluate to true. So when you start adding ands to a search, you are limiting the scope of your search down. Now, if I say you must be 6'8", and you must weigh under 250 pounds, and you must have a full head of hair, I really just limited down the population from 8 billion people on planet Earth down to a very small subset of people. And that's actually kind of a funny little thing you can go find online. Now, you can go find, like, the guys will ask a girl in the club, like, what they want, and then it's so funny. And the girls will be giving them this thing, and they'll be like, you are looking for 0.0001% of men, or whatever. It's kind of funny. But if we say or, they can be 6'8", or they can have a full head of hair, or they can be in the northern hemisphere of the planet. Well, if I say or, then I give all the people that are over 6'8", which again is a very small amount of people to be over 6'8", right? That's for you guys that aren't American, that's like a 2.3 meter tall person. That's a tall 6'8" is, yeah, it's over 2 meters and then some, right? It's a pretty big person. But then I say, and they have a full head of hair. Well, that's like half of us, right? At least we still have our hair. And then I say they're in the northern hemisphere. Now, I've made this really big list of people, probably about 5 or 6 billion people. But and only left me with like 10 people, or left me with like over 1 billion. So or is more. 5 cat bags. I got chop off at the height department. Yeah, tomorrow. Right? A very small percentage of the population, right? So then I come in here and I say add in a check that checks these things, that it is this and this. And by the way, I got to go set my SSHD check back. So I probably should have that in there. But if I do this, it'll say the system is good because HTTPD is off and SSHD check is on. But that's an and condition. So I can break this condition. I can go set the SSHD back to some other BS and run this, and the system will no longer say it's good. That's kind of a good thing. 5 cat bag. Yeah, like we'll use anything. Like how many hands tall is the person? He's a 8 hand tall person, right? Because we'll use anything. As Americans, we'll use anything to measure except the metric system. The only 2 things we use for our metric system are our guns and our drugs. No, I'm just kidding. That's not true. We also race. We do races in meters too. All right, and then I can do an or. I can run an or. And or will tell me that the system is still good, even though I've broken my SSHD check, because it's either or, right? That kind of stuff. All right, said, can I break this one? Doesn't matter if you have one or whatever. And you only need one true for the exclusive or the inclusive or to be true. All right, so that lab works. That lab walks you through some stuff. And I'm going to add something right here at the end. I'm going to add tldp.org decision structure as a place for people to go spend more time. No, I don't want that one. That's not the right spot. Bash programming in TLDP. So in tldp.org, I'm going to say this is another place. So I'm going to add this as a how-to of more stuff like to go mess with. Okay. Yeah, the -A is an and a -O is the or. Yep. Yeah, Colcus, that's why we do this, right? To just keep picking up stuff like that. You could also test conditions like that, too. You can test. That's 2 separate tests with an and or an or condition between them as well. You could do that. That's exactly right. What he's saying is this right here. We could have done this check right here. We could have added this and this, right? and then done an or like that, and that should have done the same thing. And we could have done 2 ampersands for our and. There's different ways to do it. When I did this, I literally didn't even think about this. This one should fail. I literally didn't even think about that. But you can also do the test inside of your one test construct to do ands. So this is 2 different ways to do it. This is one test construct here, right? And test is, you could also use the word test. So this is the more clear way of what we're doing. But technically, you could put the word test right there and make this work as well in a bash setting. I don't know if the -a would work with tests though, and adding more of these. But this is the or logic, and this is the and logic. It's almost always like that. But I'm going to add this doc right here. Oh, whoops, where'd it go? Did I get rid of it? Oh no. Let's go to tldp.org, and here's our how-to, and we're going to grab that, and I'm going to add this in here and at the end. Oops, get rid of that. Get rid of that. Go here, and I'm going to say in the finish right here, more information can be read and worked through here. Right? I'm just going to add that. I'm just going to add that as a thing. And I think I could do, well, I think I can do it like this if I remember my markdown right. I think I can say here, and then this can just be like this here. I think. Oh, whoops, I don't need the, I was doing my colon, my right quit. Let's added a final message, and we'll commit that, and we'll sync it, so that'll be pushed up, and then we'll go check it. I think you could test if you use the closing bracket. Yeah, that's possible. I think you would have to do test in the one, and then your ampersand, and then test in the other. I think that would be the way, because I don't know if you could do it with that -a or that O. I don't know. I've never tried to do that. But then again, I've never tried to make, like you guys know, there's this old saying for engineering, make things as simple as possible, but no simpler. So, like, once I know how to do something one way, I don't look for 30 other ways to do it. I'm a very, call me a very lazy Linux engineer, if you will. I do things the one way that works, and then I just make that thing work for me in as many cases as I can, typically. Yeah, I think they're the same thing. Yeah. I just don't know what that syntax looks like when you close it, you know? So. All right. Let's go down here. All right, let's go here. Let's run it though. Yeah, and Colchis, that's the thing, is I'm just trying to show people the basics, because I know once people see the basics of this, they're just gonna run off and be more productive than me anyways. So we can just hit check. This one will just finish all the way out, and it'll check, and then it says more information can be worked through here, and that should link us over here. That's awesome. That's all I wanted to do, is make sure that that's there. So that lab is good. We've got variable and conditional logic built now. And typically what I'll do is I'll go drop that down in the Discord that we've got another lab up. So actually I can grab the lab from right here, and I'll go drop that in our Discord and just say new lab up in Discord, new lab on variables and decisions in bash. Right? There we go. Boom. All right. What else? Oh yeah, new people showing up. You guys are always welcome down in Discord. That's always fun. What else do we have to do? I have to do this. Let me pull this up. This one is, if I save this, this is our Socratic method for Linux. I'm going to make a new one of these. I'm going to save this as the Socratic method for Ansible. And I'm going to start adding in learning Ansible through the Socratic method. And if any of you are wondering, you're like, what the hell is a Socratic method? Socratic method is just a method of debate or philosophy or learning in general, where we sit down and we ask questions, and then we answer them as a group, and we talk through the things. Most of you have probably heard like the Socratic method as like a confrontational thing, like you ask me a question, so I ask you a question back. It's not always adversarial, although it can be adversarial. But for us just learning stuff, it doesn't have to be adversarial. It's like how a college professor might just sit around and ask questions with students to see what they know and see what they think about and get different perspectives on things, right? So the Socratic method is a just way that we learn how to do things. Yeah, so that's part of it, Robodom. So have you guys all heard how? Well, this isn't how the Socratic method came about, but this was Socrates, and it was a young little. They used to call them acolytes, and somebody wanted to be as wise as him, and said, "Hey, can I be as wise as you?" Have you guys all heard that? You guys want to hear that again? Robodom probably wants to hear about it because again, he remembers it. Let's go. We're gonna call this first one. We'll call this inventory topics. Inventory topics are very big, and I'm going to delete these down because now we're just doing Ansible. And then this one will be ad hoc topics, right? And can we make that a little smaller? Ad hoc, boom. You're traumatized, yeah. So I won't say it again if it's going to traumatize people, but ad hoc. So there's that, ad hoc. Let's get rid of these ones. And then we'll leave that. And then the next one, instead of file system topics, we'll do playbook modules. Playbook modules. And then let's do getting rid of these, okay. And instead of networking topics, we'll do, what should I call this one? Salty, I feel like this when kids ask you a question, but you answer and they say, but why? Yeah, Salty, that's also them being like super annoying. Salty, have you heard the Socrates story? Do you want me to tell? I want to tell it, but I want somebody to ask me to tell it. It's like I'm like begging the question, like I want to. All right, Robodom's traumatized by it, so. All right, so networking topics. I got to change this one to be networking topics will be, so we did ad hoc playbook modules. This one will be variables, variable use. So variable use in Ansible, right? And then we'll clear these up a little bit. So I'm going to be asking questions on these variables. Let's not call it variable use. Let's say variables and looping. Let's do variables and looping because that's important. Gotta know how to do that stuff. And then come down here. So this will be how we go through and we look at Ansible. And then we'll do one on, let's say, API use. APIs are a specific module, but APIs are also, well, it's the URI module, but you can do specific things with Ansible with that as well. They can talk about what the hell subnets are besides just 255. Yeah, Salty, I can do that. I'll tell you guys the Socratic thing, and then we'll do a quick little run through of these, if that's fair for everybody. Let me grab our, where's that? Subnetting, no. Subnetting template is white in a minute and 20 seconds. Yeah, as soon as the thing's over. All right, I'll give it a second. Let me find the network primer real quick, because I know I did it in dark mode for network primer. And let me pull this up real quick. Let's talk. All right. Yeah, you probably missed this before. Hey, thanks for the the anonymous gifter that gave that to Occident Chrome. I appreciate that. But if you're in a commercial break, refresh. If you get a subscription like that, you got to refresh. I know that from being a Twitch user for a long time. But just remember that remember to refresh. If you ever get a thing and then you still get ads, refresh your browser real quick and they'll go away. I'm a Turbo user. Like, I've been using Twitch long enough that I just said, screw it. I'll do the $9 a month or $10. I think with taxes it's like $12 a month. But like, I don't see ads anymore on Twitch because those ads were like, they made me so mad I would just switch to something else because I'm always just like, switching things so fast, anyways. You know. Anyway, so all right, let's answer this real quick, and then I'll do this if that's okay. So here's the question. Here's the thing that traumatized Robodom is this acolyte asked Socrates, and you know how they lived along the coast, and he said, I want to be as wise as you. Can you tell me how to be as wise as you? And he said, yeah, sure. Meet me tomorrow morning in the surf of the beach, right? So they go out there. Occident, that's exactly what it is. So they go out and they stand about waist deep in the surf, maybe almost to chest deep in the surf. And Socrates asks the acolyte, he goes, what do you want more than anything? And the acolyte says, well, we're out here and it's morning and it's cool and you know, I want wisdom like you. So he grabs the guy and he holds him underwater for about 15 seconds. And he pulls the guy up and the guy's sputtering and stuff and he goes, what do you want? And he goes, I want to be as wise as you. And he goes, grabs him again and he holds him underwater. And if you guys have ever seen like the sculptures of Socrates, he was a big guy. He was a big muscular guy. He definitely didn't skip on his push-ups and pull-ups. So he's holding this guy under for like 30 seconds and the guy's like patting at him and like trying to get him to stop, and he pulls him up and he goes, what do you want? And he goes, I want wisdom like you, and this isn't helping or whatever. And he goes, so he holds the guy and he just holds him under. And he's just sitting there, he's just muscling this little 110 pound scrawny guy underwater, and he's holding him until the pats become weak and the guy just starts to slide down his arms, and he's just holding him. And he brings the guy up and he's like shakes him a few times. He's like, what do you want? And he's like, I want air. Like, I want air. Like, I'm dying here. You fucking killed me, right? And he's like, when you want wisdom as much as you want air, you'll have it. And that's the Socratic method. When you want this more than you want anything else, even air, you'll have it. And that's the thing. So if you guys have never heard about Socrates drowning the acolyte, that's where that comes from. All right, let me pull up my Epic pen. Let me get my Epic pen up. And yeah, I know it's kind of dramatic. The telling of it's got to be dramatic or it doesn't work. I don't think my drama's any good, but that's still my method. All right, we're going to get rid of this. And this is, yeah, an acolyte died that day because he realized that it's not, nobody can give you the answer. You have to do it. But my point is, like, that's the Socrates story. All right, so that's a complete different concept than what I'm about to talk about with subnetting. The question was, can we do subnetting and talk about it a little more than just the 255. So I'm gonna like drive the car. I'm gonna drive the car. Like, you ever see like where like somebody throws like a rock or something in a movie and the person like backs the car up all the way down the street? There's a really good Rick and Morty where the dinosaurs were driving off and he throws something at them. And he's like, oh shoot, they're coming back. The dinosaurs are like backing their spaceship up. Anyways, so where I'm going with that is I'm gonna back it all the way up for a second and I'm gonna start back in 6th grade. And some of you are gonna be like, Scott, this is so stupid. This is like too simple. And I know that. But if we've got 27 people, which is about my average college class, sometimes my college classes get up around 60. It just depends on what I'm teaching. I guarantee you there's somebody here, probably not even, they're probably just lurking, and that's awesome. You guys can lurk. But somebody here, yeah, explain it like I'm 5. Somebody here has missed this one step, and it's caused everything else to fail. Because if you don't have, it's like, have you guys ever seen, like, you can start with a domino like this big, and then you can turn, and every one can knock over a domino 13 times bigger than it, and you can go like 10 iterations and like knock a whole wall over. Have you guys ever seen that? They have like the little demos in the museums. There's a domino like this big, and then the like the 10th domino is like as big as like it would crush you if you were under it. They don't normally have those out where people can see them, but they have like a smaller version of it. But this is the point where, like, if you miss this tiny little thing at the beginning, everything else cascades and misses. It's the same thing I always tell people with like exponential math. If you've got a linear graph like this, and you miss by like one number, who cares? All you did was shift the graph down a little bit, but you're still pretty close. But if you miss in an exponential graph and move over like this, you're off by hundreds of millions of miles or whatever, and as it goes further and further up. Well, anyways, where I'm going with that, excuse me, I'm like burping over here. We had pizza and wings before my stream, so me and my son were enjoying it. You're fixing lab items today, but I had to get Salty, I finished it. I finished the lab that you made me start yesterday, Salty. I did take, I looked at those points earlier, Salty, and I almost gave them back to you. And I was like, no, I'm going to solve it today, and nobody will ever ask about it. But if you just got here, Salty, I literally just finished that lab a few minutes ago. It's still pinned. It's still the pinned lab. Now we're over here, and we're going to do some binary stuff. And let's just like step all the way back to the beginning. We're gonna go to 6th grade for most of us here in America. For the rest of the world, probably like 2nd or 3rd grade. But I don't know. I don't know. I'm in Arizona, which is like 48th for public schools, and I was in public schools most of my young life. But anyways, okay. So check this out. I'm gonna show you guys something. I'm just gonna draw something. I'm not gonna say anything about it. This is how many dollars you have in your pocket right now. You have that many dollars in your pocket. Can anybody here tell me how many dollars you've got in your pocket? Like if I said write that out as like the expanded form in numbers. You guys could all do that, I think, right? While you're doing that, I'm going to draw some stuff up here. Don't worry about what I'm doing just yet. I'll talk about here in a second. But does everybody know what that is that you're looking at up there? I do this with my college students too, so I'm giving you guys the exact same thing. Kolkus, you didn't miss anything. I jumped right to this. Check this out. There are, so real quick, $537. Does everybody agree, if I put a dollar sign here, that you have $537 in your pocket? 5 100s. Now, I'm telling it all. But if we look right here, here's what we have representative. This is 10 digits. Does everybody agree that that's 10 digits right there? So, if we have 10 states of nature that can exist here, that's exactly it, Salty, and we have 10 states of nature that can exist here, and 10 states of nature that can exist here, this is a 10 base numbering system. So 10 to the power of 1, or 10 to the power of 0, anything to 0 is 1, so this is the ones column. 10 to the power of 1 is anything to the power of 1 is itself, so this is the tens column. And 10 to the power of 2 is 100, so this is the hundreds column. So I just gave it away, but it's exactly that. This is 5 100s, 3 10s, and 7 1s. Does everybody agree with that? That's exactly what it is, yeah. So 10 to the power of 0 is the ones column, 10 to the power of 1 is the tens column, 10 to the power of 2. By the way, right here would be 10 to the power of 3, which would be the thousands column. So think about it. If I put all zeros there, or I put 999 there, I can represent 1,000 states of nature right here. Between 000 and 999, I have 1,000 states of nature that can be represented right there, right? But each location has 10 distinct states of nature. That's what we call it in a base 10 numbering system. Now, hold on. Don't let me lose you guys here. That was like 6th grade math right there. That's when you did that. And again, maybe some states that was like 4th grade. Down here in binary, I only have a 0 and a 1 I can use. So doing that same thing, that's a 2 base numbering system. 2 base, that's how it looks like there, right? 2 base. So I have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and that's the 1s, the 2s, the 4s, the 8s, the 16s, the 32s, the 64s, and the 128s column, okay? Something to the power of 0 is always 1, yes, that's why that's the 1s column. So now, this is a quick binary rundown. We're just touching it, and I'm walking you guys through some of my stuff before we talk about why we subnet. Now, Salty asked about subnetting. So I'm taking the car all the way back. I backed it all the way down up the street, and I'm showing you guys all this because we have to go the whole way, because if you didn't have this down, everything else is going to cascade and break for you. Does that make sense? So check this out. Watch this, Salty. I'm going to show you guys. I'm going to do a number here. This is 32 bits across. The reason it's 32 bits is because an IPv4 address is 32 bits long. And the mask is 32 bits long down here as well, because we mask the bits. And then we do a process called ANDing to test if something's in our network or not. But watch this real quick. Let's do a very common one. Let's do one in my home lab. 192.168. I know my handwriting's terrible with my mouse. .11.1. And I'm going to make it a /24, and that 24 right here is going to be determined. That was really funny. That sound that just came through on my speaker, on my Windows Media Player, I thought was somebody. I was like, oh, somebody followed, and then it wasn't somebody following. It was just... anyways. Okay, 16 bits are 2 to the 16 then. 16 bits are... It's still 2 to the 16, is what it's represented as. But in the last column over, you're going to have 2 to the 15 because the first one's going to start at 0. Yes. Yeah. Yep. But let's look at this real quick. Yeah. So 2 to the 16 is still 65,536. But the last number over, if you were looking at it that way, would be 2 to the 15th in that column because the first one would be 2 to the 0. It gets a little tricky there, but let's not worry about that. Let's do a practical one real quick and break it down. Now, I showed you that this is 192. I'm going to ask you guys something that when I deal with my college students, I can just tell them, go read the effing book, right? But I swear that sounds like somebody, I'm like, oh, we got a new follower. No. It's doing it again. All right, I got to change this song, guys. Hold on. The song's getting me too pumped up for, it's called The Heist from Dark Fantasy Studio. All right. That's right, Salty, but let me show you why. We could put that, and I'm not saying you did this, but we could put that in a calculator. We could. I'm not saying you did that, but I'm going to show you guys how we break it down, because sometimes people struggle with this. This is the next part you really need to know, but before I get to what you need to know, I'm going to show you something that you just have to simply memorize. And again, with my college students, I could be like, you just got to read it. Is this the Class A or a Class B or a Class C address? We look at the first octet, and we come down here, and if the first octet is between 0 and 126, it's a Class A. If it's between 128 and 191, it's a Class B. And if it's between 192 and 223 in the first octet, it's a Class C. So is this a Class A, a Class B, or a Class C address? I'm just going to ask you guys like I would my college students, right? It's a C, right? It's definitely a C. So if it's a Class C, we know that we have 24 network bits. By the way, that is right there as our /24. That's what we expect. And I'm going to draw a hard, solid line right here that tells me everything to the left is a network bit. And you say, how did you get 24? 1, 2, 3, 4, 5, 6, 7, 8, 16, 24, right? Because it's 8, 8, and 8. That's 24. However you want to get there. Now, real quick, I'm just going to step back for a second. Because that's a network bit of /24, all my network bits are masked as 1. So I could just draw a bunch of 1s here real quick. So if somebody were to ask me, what is this as a net mask? I could tell them it's 255, 255, 255, 0. And how do I know that? Because look at these bits right here. By the way, let's level set something real quick. If these were all off, we would have the number 0. If these were all on, we would have the number 255. Do you guys agree with that? If I turned all of these on, if you went to a calculator and said 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you would get 255. By the way, there's a little trick here. 128 plus 127 is also 255. That's exactly it. But guys, just like let me show you. This is gonna blow your mind, Salty. This is a trick I show my college students once they've got this. But I'll show you what the net mask is here in a second. Last chain. Watch this. This will blow your mind too, because it's an ANDing process. We AND the bits. Do you guys all remember who was here a few minutes ago? I talked about ANDing and logic. If this is true and this is true, we stay true. That's exactly how bits work in the system. But let me break this down real quick. 192, we know it's a Class C. Boom, it's a Class C. That only matters for us to find our mask, but we were already given our mask, and we could subnet further later, and I'm going to talk about subnetting in the next part, and then we'll come back to another drawing like this, okay? By the way, guys, this is up on our YouTube. You can watch this when I went through it for like 3 hours, and we have this breakdown right here on our Discord if anybody wants it. Bits follow the same logic as ANDing positive and negatives. Yes, Salty, but watch this real quick. How do I break a 192 down into this if I don't have a calculator? I can use a calculator, but how do I do it without it? We're going to start at the left over here. Kind of sounds like farting. I'm going to change this music. Hold on. The music's fine. It just sounds like it's farting. All right. Dark Fantasy Studio. This will be dark music for a little bit. 192. I'm going to come over here and I'm going to start at the left and say, can I squeeze a 128 out of a 192? I can, right? Can't I? If I were to subtract that, I would get a positive number. So I'm going to turn the 128s column on. And now I would have 64 left over. And then does the 64 fit in the 64? Yes. And now all zeros. So this first one is 1, 1, 0, 0, 0, 0, 0, 0. That is my first thing right there. I'm going to erase these just so they don't get in the way. But every time I go and do this, I'm going to be using this down here. And I'm going to do this. I'm going to do this without writing it all out, just so you guys can see. Do I have a 128? Yes. Then I have 40 left over. Do I have a 64 in a 40? No. But then I have 32. Does a 32 fit in a 40? Yes. And then I have 8 left over. Does 16 fit? No. But an 8 does. And then do I have anything left? No. That's how we just broke that down. That's exactly how we break the 128 down. Now 11. Is there a 128 in an 11? No. Is there a 64 in 11? No. Is there a 32 in 11? No. Is there a 16 in 11? No. But is there an 8? Yes. And then is there a 4? No. But is there a 2 and a 1? Yes. Now that is 1011. That is an 11 in dotted decimal notation right here. But if we were to break these down in hex, that would be a 0 right there, and this would be a B right here, right? Because 1010 is an A, but that's a B. So this is how we do this, guys. This is how we break this stuff down. One is super easy. Is there 128 to 64? No, right? It's just a 1 over here. But now, hold on. Now I'm going to knock the socks off of the people that do computer science for a second, and I'm going to show you how I calculate the network for this. Because the system, my computer gets programmed with 192.168.11.1, and then it gets programmed with a net mask of 255.0, and now my system has to figure out how does it know its network? It does a process called ANDing. Watch this. There's two ways to look at this. I'm going to tell you the computer science way is just AND the bits. The non-computer science way is think of these as a platform, and everything here stays the same, and everything over here falls off. But hold on real quick. Is this and this true? Yes. Is this and this true? Yes. Is this and this true? No. Is this and this true? No. Now hold on. If I did that all the way down, for you guys that are kind of astute, which I know, most of you are probably picking this up like this, wouldn't you all agree that instead of just doing this, I could say that it's 192.168.11 because nothing to the left of this line changed? But I could keep doing this if you all insisted, right? Boom. And then this is ANDing to true, this is ANDing to false, this is ANDing to true, this is ANDing to false, this is ANDing to true. Do you guys see what I'm saying? All of this is the same. So wouldn't we agree that, and then over here, by the way, this is going to AND to 0, so this is going to be 0. So the network for this is 192.168.11.0. That's how it works. It's an ANDing process. It's this bit and this bit, true. This bit and this bit, true. This bit and this bit, false. But, again, for you guys that don't want to be computer science buffs and think about ANDing, this could just be a platform. And they all stay the same on top, and it doesn't over there. Yeah, you lose the 1, because I'm not on the network 192.168.11.1. I'm on the network 192.168.11.0. My host is the .1. All right? So that's how this works. Now, I need to show you guys something because I'm about to talk about this in a big grand sense and then come back down. But I think this is going to make sense for a lot of you that are tracking. This right here is the numbers, but this right here can represent in this network 0 to 255. We all know that if it's 0, that's the network, right? Did we just say that 0 in this last octet, 192.168.11.0 is the 0, that's the network? And if I turn all these bits on, that's the broadcast, 255. So I've got 254 usable hosts in that space. Does everybody agree with that from what I've shown you so far? Now I got to explain something to you. If you're in a network and you're all in the same network, it's like we're in a big room. And I'm yelling at 255 to yell at all of you. So let's go look at this next part real quick. And I promise you this will make a lot of sense for subnetting when I show you this. Why do we subnet? Here's the 0, here's the 255. You were given that /24, right? By the way, guys, if you want to see this again, it's on YouTube. And I have it uploaded there as our Linux networking primer. So I've been teaching this for 15 years at the college level, guys. This is exactly what I show my college students. This is exactly the mathematical theory behind it. It doesn't get any harder than what I'm showing you right here. Well, there's variable length subnet masking, but I'll do a primer on that one of these days. Actually, I'll probably add it to the primer. So now, this is a big network, and I'm yelling at everybody. It's just YT for YouTube. But it's just yelling like this. And what if I wanted to run a college class over here, and Salty wanted to run a college class over here, and then last chain wanted to yell up here, and we could talk to our students individually, but when we broadcast to the whole room. I always think of this as, have you guys ever been in one of those big ballrooms at like the Wynn or something like that, and they can bring those like they can slide those walls in and partition the room up? We can do that. That's what borrowing bits for the subnet mask is now, or for the subnets are. But this is why it's important. When we borrow bits, so we're given a network space. This is the network space we just looked at, except it's 192.168.1.0. There's 256 total addresses. You cannot use two of them. 0 is the network, so it goes away, and 255 you can't use, right? Yeah, we're over on YouTube as well. Yeah, trying to grow the stream, trying to get more people interested in doing this stuff and hanging out. I'm going to take one of those bits that I had. Remember I said that there were 24 network bits? I'm going to borrow one more bit, and I'm going to make two networks. I'm going to carve this room in half, like this. And when I carve that network and borrow a /25, because it was /24, we borrowed one bit. Now I've cut that room in half. 0 to 127 is my first network in my first broadcast now, mathematically. And 128 and 255 are my next network and broadcast. And those are the ones I can't use. So in here, I have 126 usable addresses. And down here, I have 126 usable addresses. But what's so important is I can yell at 127 and only you guys hear me. And then Salty can be down here yelling at his students and only they can hear him down there. The yelling, the broadcast domain has been split. Now, let's keep doing the math and let's borrow one more bit, right? You get to a network, and I tell you guys all the time, I tell my students this all the time, you get to a network that was already carved up by a previous engineer or a previous architect. We have to use what we have. So now they've borrowed another bit. They're using 2 bits. And I'll show you what this looks like when we go and borrow those bits. But understand that we could use 00, 01, 10, and 11 in that space. Well, we're counting by 64s. So it's the 0 to 63 network, the 64 to 127, the 128 to 191, and the 192 to 255 networks. When I go flip this back over, this is all going to like snap in place for some of you. For others, you're going to need to spend more time with it. And I promise you, and just like I tell my college students, nobody gets this. There's probably like 2 people that ever got this the first time. They're all math whizzes. The rest of us, you got to look at it a little bit. You got to chew on it a little. Let's borrow one more bit here. So now we've got 3 bits borrowed, which is 8 states of nature. We've got 8 rooms. And we're counting by the 30 seconds place. So 0 to 31, 32 to 63, 64 to 95. These are all of our networks. And they're all like little rooms from that original room. They're all 1/8 of the original size. They look like a normal sized classroom. Okay, I love it. It couldn't fit everybody in here though, so I love that. This is slightly different because we're doing multicasting for this. This is you registering in and getting multicast, and then it sends to a multicast address and it goes to everybody that registered, but it's a different concept. Oh man, I'm losing water. That's not a simple thing. That's not part of our primer. Our primer is to tell you guys stuff that you're gonna run into as Linux systems engineers and high performance compute engineers and programming stuff. Oh, did I like go to my crescendo and then it went to a commercial and everybody missed it? Damn it. Well, on the plus side, it's probably over on the YouTube. All right. So let's take all these things I did right here and let's go back to this. And let's now chop those up. Because I showed you a raw network. I showed you just the network. I showed you this to start up here. So up here, we did just that one network carved right here. Now I'm going to borrow each of these bits and break it down for you, right? So now I'm going to take us all the way to here and show you how this works mathematically. Because I'm telling you, once you do this stuff mathematically, you're like, that's it? It's again, for some of you, it's going to snap like that because you've been doing this a long time and you're just going to see it now. For others, you got to play with it. You got to chew on it. I didn't learn this the first day. I think I told you guys, I took 4 Cisco classes in college. When I was in the Army, I took 4 Cisco classes, passed my CCNA the first try, but it was a bear for me. And I tell you guys this, and you think I'm joking around about this, but when I passed my CCNA, I could not tell you what a server was. Did not know what a server was. Oh, by the way, if you're looking for those other things, there's those other things. They just deal with masking and bits over there. So you're not really missing anything by me. And you're not I love that. All right, let's break this down. Actually, let me take a break real quick. Let me go take a quick uh, thing, and we will do that. I'm gonna go hourglass. Give me a quick break. Let me see how my son's doing. He's over in the other room. We'll go grab me a monster. Mr. Poolshot, thanks for coming by. We are doing stuff. I want you guys to think about reviewing these if you want. Give me 1 second, and I know I'm not supposed to break those on stream, but actually I'm going to take 8 minutes. But I'll be right back. I'll go check on my son. We had pizza earlier, so he's probably pretty happy. I'll be right back. All right, I'm back, but I still got some break left. By the way, if you guys have if you guys have missed this before, this is all up in the Discord. It's in the networking section, and I used to put up little examples for you guys to try. And if you guys were like, "Hey, I want to work through those," I would do more of those. 31 hosts per subnet. That's right with /27. Yeah, that is right. 8 subnets, 30. You got 32 usable. Sorry, you got 30 usable per 30. So how many hosts per subnet is this equation here? To the power of h minus 2, which is 5. 32 minus 2, so you got 30 usable. Because you have to throw away the network, which is, well, not always 0, but you got to throw away the network, and you got to throw away the broadcast. I'm going to show you guys how I do it up here. Oh, they're hidden behind me. Yeah, let me pull me off real quick. 255 is the broadcast salty only in the first network when we're at a /24. When we carve this up, the broadcast is for each network, and I'll show you how we find that real quick, okay? So just follow along with me real quick, and we'll do a review of the other stuff. We're going to do the same one, 192. It'll be slightly different. 192, 168. Whoa. That's a 168, guys. 1.0/27. Now, it's the same as before, but we could also say nothing to the left of this matters. That's our first line. That line is because it's a Class C, and we had 24 network bits originally given to us by the fact that it was a Class C. So those over here do not change. These do not change over here to the left. And if I were to start, I could do 192 is a 128 plus a 64 with no other bits on. 168 is a 128, and then there's 40 left over, so it's not that. It is that. It's 8, so it's not a 16, and it is an 8. That is 168 in binary. Because there's a 128, there's 40 left over. That doesn't work. It does there, not there, does there. Okay. And then 1 is here, so 0, 0, 0, 0, 0, 0, 0. And then 0 over here, we'll just leave that as a 0 because it doesn't matter for right now. Now, that's 24 bits. So this is 8 host bits, or 8 network bits, 8 network bits, and 8 network bits. But I need 3 subnet bits over here. So I have 3 bits that are being used as subnets now by my team or whatever. And I said earlier, so zeros right here. Boom. Now, if these are the subnet bits, I'm going to count up all the states of nature, all the networks that can exist. There's 0, 0, whoops, 0, 0, 0. There is 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Does everybody see that? But the 3 subnet bits gives you 8 unique addresses. Sure, but look right over here. Subnets are 2 to the power of s, which there are 3 s's. So subnets are, there's 8 total. So we could have answered this with 8 right here. And then how many hosts per subnet? Well, we got 5 host bits, but I'm going to show you why we counted them like I just did. It's going to blow your mind here in a second. Watch this. My host bits are 2 to the power of h, 32, minus 2. So I have 30 hosts per subnet. But watch me. This is going to blow your mind here real quick. The network is always going to equal all host bits equal to 0. And the broadcast is always going to equal all host bits equal to 1. So let me show you this real quick. Do you guys see how right here we were counting? We went 0, 0, 0, 0, 0, 1, 0, 1, 0. If I asked you to tell me all of the subnets, you're just counting by the 32s. So there's the 0 subnet, there's the 32 subnet, there's the 64 subnet. Look how these numbers align. That's 0. Those are all zeros. That's the next subnet. The next subnet is a 1 in the 32's place. The next subnet is just a 1, 0 in the 64 place, right? The next one is 1, 1, which is the 96. That, by the way, aligns to all the numbers we saw earlier. You might need a cigarette at this point. Well, allow me to show you then real quick how we get all of the hosts. Again, remember, all zeros is the network and all ones is the broadcast. So if I took all zeros here and added all zeros here, would everybody here agree that I would get a 0? Yes. Then if I took all ones here, what are all the numbers that are 1 less than 32? I would get the number 31. The next network is the 32's network, and all these are zeros. So this is the next network. It's 32, 2. I'm going to turn on all the host bits over here, and I'm going to get 63. Then I'm going to go to here, and this is my next network. This is the 64 network. And I'm going to, that's 64 because it's 0, 1, 0, and all these are zeros. Then I'm going to turn all these on, and I'm going to get a 95. And that is how I'm going to find all the way up. The next one's going to be 96. By the way, 96, when I look over here, is a 1 and a 1. It's a 1 in the 64s and a 1 in the 32s. That equals 96, right? That's this one right here with all zeros. And then if I add all ones over here, which is 31 higher, that's 127. I've went halfway up it. Do you guys see how I did that? I'm counting by 32s. By the way, guys, there's a trick here. There's a sneaky trick. If you were like, oh man, like it's so hard and I got to do this on my Net Plus and it's going to be so hard and oh god, how am I going to do it? And you're like, you start turning into, it's game over, man. It's fucking, we're dead, man. We're fucking game over. Who's that? Did I do him right? I know I do him well. It's game over, man. We're just go nuke it from orbit, man. Here's the trick. All in order. Yeah, so I could just go, watch, I could just keep counting up here, 128. Here's my trick. Did you know that the number before is always one less? So I could do this all the way up, 160, and I could just go all the way to the top. I'm a slippery little snake, right? 192. I can go all the way to the top, and then I can just come down backwards and say, well, that's 31 because it's one less than that. That's 63 because it's one less than that. That's 95 because it's one less than that one, right? That's 95. That's 127 because it's one less than that one. So you're being sneaky. And we're all dealing only in this last octet here, obviously, right? We would always have a 192.168.1 on the front of all these, but that's it. But wait, what I was doing Bill Paxton, right? It's game over, man. It's fucking, we're all dead, man. Alien 2, right? Or Aliens, right? Come on, somebody tell me I was doing that right. God, all right. If I wasn't doing that right, then I failed. All right, I failed if I can't get my Bill Paxton down. Oh, and then he's talking. Remember when he's talking about Arnold's wife in True Lies? He's like, I can't even say it. I'd probably get like a violation for the kind of stuff he said in that movie. This 159, right? Because it's one less than that, and then that's 191. Yeah, like I'd definitely get a strike for saying some of the stuff. Yeah, I got a little dick. Would a spy piss himself? This goes all the way to 223. And then the last one's 224 to 255 if you care. But the point is, I don't want you guys to memorize these. Like I always tell my students, don't memorize this stuff. Learn the pattern. Because you can go take these right here that I just counted up for my S's, and you could put them in over here and figure them out. Right? You could figure out any one of these. And this is exactly how subnetting works. Right here. Now, might you need to see it a few times, and might you say, well, Scott, what could you show me that 25? Let me show you. If I did this all the way out, and I started with, I'm going to start with the first one. I'm going to go 192.168.1.0/25. That was the first one I showed earlier. Remember, that cut the network exactly in half. And I draw this line here because nothing to the left matters. And then we break this down. 128 goes into that. 64 goes into that, so there's nothing left. Boom, right? Done. 168, does it have a 128 in it? Yes. Does it have a 64 in the 40 that's left over? No. Does it have a 32 in the 40? Yes. That leaves you with 8. Does it have a 16? No. Does it have an 8 and an 8? Yes. No, no, and no, because I have no numbers left. 1. Is there a 128? No. Is there a 64? No. Is there a 32? No. Is there a 16? No. Do you guys see why I'm doing that? So people pick up what I'm doing. 8, 4, 2. There is a 1 in 1. So I have to do that. And then I only borrow 1 bit. I only come like this. And I only borrow 1 bit as my subnet. So I've got 24 network, 1 subnet, and 7 host bits over here. I don't want to draw them all out. Now, real quick, if we were just looking at this, we're counting by the 128s column. We have 2 states of nature. We can have a 0 and a 1 right here, which means that we can have the network 192.168.1.0. So we can have a .0. And then if that's a 1, we have a 128. We have a .128. There's our 2 networks. How many subnets? 2. That's a 24 for now. That's 25. That's 25 for now. 25, right? How many hosts per subnet is you take that 7 right there, which is 128. You do, so 2 to the power of 7 minus 2 is 126 per. So we come over here. We've got a 0 in over here at first for our first one with all of these as zeros. If I make all of every one before 128, I add them up, I get the number 127. And then 128, if I add all of those up, I get a 255. Those are my 2 networks. This is my trick that I didn't show you guys earlier. Here's my trick. If I was counting these, and I counted all the way up, and I had 1, 1, 1, 1 here, that's 15 right? That's hex F. But for us, it's 15 right here. And I want to add one more. I want to add plus 1. You guys agree that I put it right here, right? Well, what happens to that? I had 15. What's 15 plus 1? It's 16, right? You guys see that? It became a 1 here. Now, if I had all of these on, that's 16 plus that, that's 31. So if I had 31 plus 1, I would get 32, and these would all be zeroed out. And if I had 63, so what I wanted to show you guys is, if you ever see a number that's just, if you see like this and it's all ones right here, it's 127. It's one less than 128. So that's a quick little trick that you can use. If you were to ever see like this, 1, 2, 3, 4 here, that's 15 because it's one less than 16. Does that make sense? It's quick little ways to shortcut this. But I show you guys the long way because then the shortcut ways come when you take your Net Plus or your CCNA, because you have to do these in your CCNA. You have to, well, you don't have to. I tell my students all the time, they're not going to make you do this. This is a template that I use to teach this because I think it's a good template. What I tell my students is they're going to give you a set of networks, and you better know if they're right or not. Or if you have to say that's a wrong network. And the only way you're going to do that is if you learn these patterns and kind of set them in your brain. You guys ever see ever read the book, I think Neil Stephenson wrote it. It was called Snow Crash. Anybody here ever read Snow Crash? Really great book from the early 90s, and he's talking about all this stuff. Like he predicted all this stuff that was going to happen in computers, and it's really great. But one of the things about it was when you were down in this virtual world in like the early 90s, somebody could show you this paper, which was dude, it was a freaking QR code, but it was way back then. And they showed you this paper, and because you had been a programmer and had set all these like kind of pathways in your brain, it actually downloaded a virus to you in real life and killed you. So it was the first, in that book, you were in like this virtual world, and you can go look it all up about how they did all their subnetting and stuff. It's pretty cool because the guy was a technologist. He came from IBM, and he wrote a couple of really good books. Snow Crash was one. I think he wrote Cryptonomicon as well. Is that him? Hold on. Now I gotta look him up so I don't look like. I mean, I'm already an idiot, but Snow Crash. Snow Crash was Neil Stephenson. Excellent book. Really good. Has almost nothing to do with what I just described. And can I tell you guys? I'll tell you guys one thing about this book. He was already a best-selling author by this point, but he does the most arrogant thing I've ever seen an author do. Can I tell you guys the one thing? You're going to see it on page 1. It's not a spoiler. I hate spoilers. I would never tell you a spoiler. His main character in this book, his name is Hiro Protagonist. His main character is Hero Protagonist. That's his name. Hiro, Hiro, Hero Protagonist. I think you have to really know you're writing a bestseller for that to work. But that's an excellent book. He also wrote he did Snow Crash, and I think he did Cryptonomicon. Did he do Cryptonomicon as well? God, that's a good book. Don't read any spoilers on it. Just go read it if you want to. But it's pretty good. Okay, I'm gonna change the song because it sounds like we're in an office getting calls. But I think that's the point of it. All right. What else? So we did all that. We did subnetting. We broke this stuff down, and then we kind of got into OSI model, and we talked about how things talk logically across and physically down, and we broke all this stuff down. Right. This is up on the thing. If you guys ever say, hey Scott, I want you to go over that again on like a Friday afternoon or something, I'll do this whole talk again. I've got things to add to it to make it better as well. But this is recorded in like a 3-hour thing on our YouTube. So you guys are welcome to go up there and grab all that stuff. Talking about all this stuff. We broke all this stuff down, right? It's just a bunch of stuff that I think is useful for you before you get into systems world. Even though it looks like, oh, hey, this is all networking. Yeah, but no, it's important for you guys to know it. All right, I'm going to clean this stuff up a little bit. Hold on. I'm cleaning up this. So we did API use, and then instead of security topics, we're going to do... let's say reporting with Jinja 2. Let's do reporting stuff, so we'll have that stuff going too. And let me see if I have any more of these to come up. Encrypt those. Can we do that? General system, we don't need that one. I'm cleaning this up. This was something we were looking at earlier, guys. This is I'm carving up a different conference presentation that we had. User environment. We don't need that. Not for this part. Let's do this one. This one will be bash scripting will be. Oh, let's copy that one. Say instead of bash scripting, that we have. Gotta clean my keyboard off. Got stuff between my keys. Okay. Can you touch the file system? And then this one was gonna be. What was I gonna do? Let's say roles and galaxies. In case somebody's already struggling with that one, or they're struggling with what that stuff looks like. So I'm going to make this into one that loops and goes over all of that stuff. APIs is in Kubernetes. No, this is different. This is, so this actually, I'm going to do a Kubernetes one of these as well. But this is, we have a Linux one that's been playing the last few days where all it does is it walks you through, it's just a bunch of questions around doing Linux. And we've been doing them on stream and stuff. That's why I haven't been focused on it this stream. But I'm going to do another one that's just going to walk you through. So what will happen is, as we're sitting here talking about other stuff, this will be up in the corner. This will be up there. It'll be a little smaller and it'll fit up there. But it'll look more like this, right? And then, oops, wrong one. Like that. Like that. And it'll be up there in the right corner. And then it'll go through as we go. It'll be fit up there, right? And I'll have this off to the side so it's not in the way. And as I'm working on whatever, these things will go through and it'll be asking you questions about can you do certain things inside of whatever lab we have going. So let me get rid of this lab because that lab is a good lab, but we don't need to do it right now. And then what this lab will do is I'll probably have it like 5 minutes for each of those, and it'll just ask you questions about Ansible, and then you can go and do stuff with Ansible. You'll be able to go practice some topic, and if we need to, I'll stop it and we'll go over whatever that topic is and kind of work through it. So it'll be good. And Cold Kiss, you're probably gone, but yeah, I appreciate you coming by. It's always good to have you guys stop by and do this stuff with me. So, all right, where are we at? Man, I'm over 2 hours already. All right, I'm not gonna strain myself too much, but for tomorrow, anybody that comes by tomorrow, does anybody know what we do all Sunday? All Sunday morning, what do? We do one thing on Sunday mornings, labs, right? So we'll start in a version of some part of the labs, probably down in, oh shoot, maybe we'll just start in the Linux ones and we'll just do labs the whole day. It'll just be us working through whatever the lab says to do. We'll do that. I'll probably pull up the book. We've got a book. I tell you guys, I published it through LeanPub, so I had to charge something. I'm not telling you guys to go get the book. You can do the labs without the book. If you want more, and if you want to dig deeper in, the book is like a lab guide that just gives you more questions. It's kind of like your journal of what you're working on and kind of going through. And I actually have to add to the book. So maybe tomorrow we'll work through some stuff and I'll add to the book as we go, because I have a little like a portal inside of LeanPub where I can keep adding this stuff as we go, and then I can keep publishing the book. So LeanPub's cool because I have some books from LeanPub that I've bought where anytime somebody updates it, you get the update. You always get the update, so that's kind of a cool little thing about it. All right, let me go to my little end of stream thing here. If you guys have any last questions for me, let me know. But for the most part, we're going to drop off. Fisherman, I assure you, none of you guys want to hear about that. But I can tell you this for sure, that you just need to make sure that you're working on stuff. It doesn't matter what you're working on or where you're working on it at. Just be doing something, right? Like you gotta kind of take charge of your career. There's nobody coming. There's nobody to help you. I mean, you can pay people to help you, like with college and stuff like that. But other than that, man, like you're really responsible for your own stuff. So I want people thinking about that. Like find a group. If it's not our group, find a group somewhere that resonates with you and that you can work with those people and learn how to do this stuff. This or find somebody doing DevOps stuff. We do a lot of DevOps, but I'm not doing that. I'm not focusing on that right now, right? But there's like all kinds of things that you guys can do and start getting in there and getting better at this stuff, all right? Okay, so that's that. Actually, you know what? I'm going to start making another one of these. I'm going to start, maybe by tomorrow I'll have the Kubernetes one done. So I'm going to have all my stuff for learning CKA into one of these as well. So that'll be going as well. So we're going to have a bunch of different labs that we can work on tomorrow. And yeah, we'll start doing that. That'll be fun. Speaking of DevOps. But anyways, okay, I'm going to find, let me see if I can find somebody to raid real quick. Let's see what's going on out here. Robitech. We're going to hit Robitech up. They must have just started because they normally have a lot more people than that. So let's go raid them real quick, and I definitely appreciate you guys all coming. Make sure you guys follow over here on Robitech because follows are free, right? They don't cost you nothing. And whatever else you do, I appreciate you guys stopping by. All right, take care.